You will see on a tab called multiplying and dividing fractions, I have two sides of the spreadsheet. The left-hand side here, well, the far left has some rules for multiplying and dividing fractions. The middle column here is us practicing by hand. And this last area is going to be, well, how do we do this in Excel? So let's first practice doing these by hand. Perhaps that in your class you are doing a lot of these types of calculations by hand. So that's where we're going to begin. So I am going to switch over to my iPad. All right, we should see the same type of information here. So we're going to first look at multiplying fractions. So there are three steps for multiplying fractions. The first thing is to multiply your top numbers, the numerators. The second thing is to multiply all the denominators, and then we want to simplify this fraction if needed. So let's head over here to that first example, problem number 1, where I have 3/5 times 4/7. So our rules said we're just going to multiply this straight across. So this is going to be 3 times 4 over 5 times 7. So that's going to give us 12 over 35. Well, the next step says to reduce this if possible. So what we need to do in order to figure that out is we really need to go back and revisit this step right here. We look to see, do we have any common factors that can reduce out of the numerator and the denominator? And we can check, does 4, is it a factor of 5 or 7? And the answer is no. So then we ask, what about 4? Is it a factor of 5 or 7? The answer is no. So the fact that both of those are no's, this tells me that this is the reduced version, or reduced form of our fraction, 12/35. All right, let's move on to example number 2. Again, here we're multiplying, and notice that the instructions for each of these say a little something different. We have multiply, simplify, compute. So we can use lots of different vocabulary words to describe multiplication, where the multiplication comes in based off of the operator that you see in this mathematical expression. Now, in problem number 2, multiplying fractions, again, we want to multiply going straight across. So this is going to be 3 times 4 over 5 times 3. Now, once we get it over the same fraction bar, we can see that we do have a common factor here of 3. So before I multiply across, I would like to do what's called cross reducing. Let's go ahead and reduce out that 3 for my numerator and denominator, leave me with the fraction 4/5. Now, if I had not have reduced that 3 out, I would have got 3 times 4 over 5 times 3. I would end up with 12 over 15. And then I'd have to go through all the factors of 12 and 15 again. And then I would say, oh, that reduces to 4/5. So if we do what's called cross reducing first, that's going to help us get to our solution faster. All right, let's look at number 3. Let's compute 3/5 times 5/7. So that's a 3 times 5 over 5 times 7. My little 5 is a little sloppy here. Again, now that I see that we both have a 5 in the numerator and in the denominator, we can reduce that out, leaving us with the fraction 3/7. Are there any questions so far? All right, looking at problem number 4, we have a whole number times a fraction. So when that happens, let's write our whole number as a fraction. So we're just going to write that 3 over 1. So this is going to be 3 times 4 over 1 times 7. I see no common factors in between my numerator and denominator. So this is going to give me 12/7. Now, in this situation here, I see that my denominator is actually smaller than my numerator. When that happens, we call this an improper fraction. And if you recall elementary, middle school, we worked really hard at changing improper fractions into proper fractions. And if we were to change this to a proper fraction, we would say 7 goes into 12 one whole time. So I have one whole, and then I have 5 left over out of 7. So this would be the proper fraction equivalent, also known as a mixed number. So again, in elementary school, middle school, we worked really hard at turning fractions into proper fractions. And then, once we hit algebra, all that kind of went out the window, right? We say we leave it in improper fraction form. Most of the time we're using decimals and we go from there. So this will probably be the way that you'll see it, if not also a decimal. All right, problem number 5, we have 4/9 times 3/1. And when I look at these numbers, I don't necessarily see the same number in the numerator and denominator, but I do have a factor that exists in both. We have, because 9 is really 3 times 3, I can reduce this by taking out a factor of 3. Now, when I do that, that leaves a 4 in my numerator and a 3 times 1 in my denominator, or just 3. So we're left with 4/3. So this is how we multiply fractions. All right, I'm going to be moving on to dividing fractions. Do we have any questions before moving forward? If so, you can raise your hand. All right, simplifying using division for fractions. So the rule for dividing fractions is we keep our numerator. So when you see this division, this is really like seeing 3/5 divided by 4/7. So we keep the numerator as it is. We flip the division into a multiplication. Sorry. Let me change my words here and not say flip yet, because it is like we're flipping. Keep, change, and flip. So we keep the 3/5, we change the division into multiplication, and we flip, also known as reciprocal, find the reciprocal of that fraction that we're dividing by. So we're going to flip that fraction to 7/4. Now that we've turned division into multiplication, we're going to use the same skills we just practiced up above. So we have 3 times 7 over 5 times 4. We get 21/20. 3/5 times 3/4. Keep it, change it, flip it. Multiplying straight across, we get 3 times 3 over 5 times 4. So we end up with 9/20. Here we actually see a fraction within a fraction. This is known as a complex fraction. We take our numerator, we leave it as it is, we change that division to multiplication, and we find the reciprocal of our denominator. So we have 3 times 7 over 5 times 5. We end up with 21/25. All right, you tried number 4 and 5. You do those on your own piece of paper using your knowledge up above. So if we have a whole number, we're just going to write that over 1. Did you get 21/4 and 4/27? All right, we are going to now head over back to our Excel. So I'm going to switch my screen again here. And now let's practice just some of these. We don't have to do all of these using Excel. So in this example here, I want us to complete the following using Excel because Excel is going to be a tool that we're going to be rely heavy on in Math 143. So let's take some math that we know how to do by hand and let's let Excel do the calculations for us. So if we were going to write this answer as a fraction, just a little summary, just in case you don't know that these cells that we have in Excel, and I have formatted this just for learning here. You can format these to look however you want. In other words, if I want this to be shown as a fraction, up here under the number, we want to select, hey, I would like to see a fraction. Now, if I type in 3/5 times 4/7, I have to first use an equals. And because I have two fractions, I'm going to use parentheses. So I have 3 divided by 5 times 4 divided by 7. Now, when we did this calculation, we said the answer was 12/35. So what the heck is Excel doing? Well, I will show you. So what's happening here, Excel is rounding fractions. So this is trying to round the fraction to the nearest half. So we need something more precise than that. So we have to alter the format of that cell to say, hey, let's give us some more digits. So we're going to click on more number formats. And you'll notice that because I've already changed the format to fraction, I can go down here and I can expand that. I'm going to just put up to 3 digits and hit OK. Now I see the fraction that we had when we did it by hand. Now, notice the icon up here is fraction. And now, if I click on this, it's going to go back to that 1/3. I don't want that to happen. So I did that by clicking to expand that, and I changed it to say, show me up to 3 digits. Now, if I want to copy this particular format, I can right click and say copy, and I'm going to say I'm going to use it here for the next one, and I can just paste the formatting. So you'll notice that here I have an option for formatting. I'm just going to paste that here. So when I go down to my next fraction, 3/5 times 4/3, it has carried that formatting for me. We want to do that again. Fraction, 3 digits. This is basically if you have to display a fraction in Excel. All right, so now let's practice these 3 examples, turn them into decimals. And by the way, if you wanted to see what this looks like, I'll write the formula over here to the right. Put my equals on this side for you. All right, so here we're showing you some formatting. You'll see that I'm manipulating in Excel to display the content as I want it to show. All right, so how do we convert these to decimals, rounding them to the hundredths place? So you may recall that the hundredths place means we need to see 2 digits. So this is going to be equal to, we can do the same calculation. So this would be 3/5 times 4/7. And you'll notice that by default, it gives me a decimal. So when you have the format as general, it's going to give you that decimal. Now, if you want it just to stay number, you can click on number. And you can also manipulate the number of decimal places you want to see. And you'll notice that I'm manipulating that up here in my number option. Or you can manipulate it by doing format cell, right clicking, and you could say how many decimal places do you want to see. So the decimal equivalent of this fraction is 0.34. And then that would be an approximation since obviously we had to round some of the numbers. All right, let's do the same thing. So we have 3/5 times 4/3. We hit enter. I'm going to say, give me a number. Round into the 2 decimal places, so I'm good with this one. We have 3/5 times 5/7. Let's change that one to a number. And again, I have that one already rounded to 2 decimal places. So that's how we could use Excel to do this calculation for us if we wanted our answer to be a decimal or a fraction. Now, I do want to show you what happens if you have an improper fraction. So let's take a look at number 4. So for number 4, we want to put in 3 times 4/7. Now, it's putting it as a decimal, so I could probably go ahead and copy that over. That's what it would look like as a decimal. Let's go ahead and round that to 2 decimal places. But let's change this first column here to a fraction. So we need to change it to a fraction, and we want to display as many digits as possible. Now notice that Excel wants to turn it into that proper fraction. And so that is the equivalent to the fraction we got, which was 12/7. All right, so the purpose of this was to show you how to multiply, divide by hand, and also how to multiply. And we're also going to look at divide fractions using Excel. Are there any questions about using Excel to multiply? If not, I would like for you to go down to this next table, and I would like for you to practice dividing these fractions using Excel as well as finding the decimal. I'm going to put myself on mute for just a second, and I'm going to make a call in to some other students that are trying to get in. So I'll be back. All right, so when you're doing the division of our fractions here, it's going to be the same kind of setup. We're going to say equals. And because we have fractions, I'm going to use parentheses around each fraction. I have 3 divided by 5. And then I'm going to also divide that by 4 divided by 7. Now, probably should have listed the decimal first. I'm just going to head and copy. And I'm going to paste that over. So you'll see that up here, this is called a formula bar. You'll see the content of that is sitting inside. That is the content inside of that cell. I want to turn this into a fraction. So I can do so by doing my fraction here. We get 1 and 1/20. And if you recall, that is one of those that was 21 over 20. So that looks good. We have 3/5 divided by 4/3. So we've got this equation here. I'm copying and pasting, and I'm going to just copy my formatting here. I'm going to right click, copy, but I'm not going to copy the values. I'm going to copy the formatting, and it turns it into the fraction 9/20. All right, let's try this next one. We have equals. We have 3/5 divided by 5/7. And recall when we did that by hand, we got 21 over 25. So let's copy, paste our formatting, and we do indeed get 21 over 25. All right, just to show you how we would handle a whole number in a fraction, we would say equals. We have 3 divided by parentheses 4 divided by 7. Again, if I wanted to change my formatting, change it to a fraction, and we get 5 1/4. Recall that when we did it by hand, we ended up with 21 over 4. So that's equivalent to that 5 1/4. All right. All right, let's take a look at some exponents. Exponents and using PEMDAS, which is our order of operations. So about exponents, what is an exponent? An exponent is when it refers to the number of times a number gets multiplied by itself. So for example, if I have 2 to the third power, this makes it an exponent. 2 is the base, 3 is the power on that exponent. We read that as 2 to the third, and it means 2 gets multiplied by itself 3 times. So 2 times 2 times 2, which is equal to 8. So 2 to the third power is equal to 8. So that's how we would handle that if we were doing it by hand. Now, if we're using Excel, Excel can do that for us. So let's go backwards and let's just look at Excel first. So over here to the right, I'm gonna just go over to my table here. It says simplify 7 to the third power. So how we would do that is we would type equals and we would write 7, and you can use a caret. And to find that caret, that would be shift 6. And we would say to the third power. When we do that, that gives us 343. That's how I got that. Now, there are other functions inside of Excel that you can use, but this is the most common, so we're just going to use the ones that are most common. All right, let's simplify this fraction, 3 over 5 squared. So because I have multiple things, when you're using fractions, just always use parentheses around the numerator and parentheses around the denominator. So my denominator here is going to be 5 squared. So this is going to be 3 over 25 if simplified by hand. But here it gave me a decimal. If I wanted to see this value as a fraction, I can take it, change the formatting to a fraction, and we would see its equivalency right here. All right, let's try the next one. So with these, we have order of operations going on. So order of operations is a rule that tells us the correct sequence and steps for evaluating a math expression. For example, we have PEMDAS. That is the one that we've been told since we were wee little. And PEMDAS represents take care of parentheses first. Then we move on to exponents, exponents such as powers, square roots, and things like that. Multiplication and division are on the same level. You just move left to right. So if there's both there, you do multiplication, then division, whichever you see first. And then the last two are addition and subtraction, again, left to right. So dividing and multiplying, they rank equally. You just read it left to right, and that's how we would solve it. So parentheses, we have exponents, multiplication, division, addition, or subtraction. So For the problem over here, if we're using Excel, we don't have to worry about that. We just have to make sure that we enter it in the way that it's given. So we're going to say equals because it's a mathematical operation. So we have to say 1 plus. Now, because Excel is also a place for you to type in letters, if I just do parentheses here, it's not going to know what to do with behind it. So the implied operator between the 3 and the 4 squared is multiplication. So we actually have to explicitly say multiply times 4 to the second power. So this is the rules for typing that in. All right, let's try our next one. So we have 4 plus 2 times parenthesis 5 minus 1 in that parentheses caret 3. Simplifying, we have equals, parentheses. Again, these parentheses matter. Here we have a negative on the inside, so we want to make sure that we copy that the exact same way we see it. We have negative 3 raised to the second power. And that's exactly the way we entered it in. Now, just for the sake of argument and seeing what would look like if we didn't use parentheses, if we didn't use parentheses, we did negative 3 power 2, what would happen? Well, looks like they interpret it the same way, but I would not, your calculator would not do that. So we're going to just scratch that off. That is not good practice. We want to use parentheses. All right, number 6. So we have equals 4 plus 2 times parentheses 3 minus 2 parentheses caret 3. And we end up with 6. So notice that in Excel, using Excel as our calculator, basically the work is just you putting the information into that cell. So we do have to practice manipulating in Excel. If you want to edit, you can also edit using that formula bar up here once you've entered it in, if you needed to manipulate it. All right, let's practice using exponents with our fractions. Are there any questions about, first of all, using exponents here with just these expressions before moving on? If you're still with me, give me a thumbs up. All right, let's simplify 3 squared over 5 times 4 over 3 squared. So we've got decimal and fraction here. So I'm going to start on the decimal side. So we have 3 caret parenthesis. Actually, I need to do divide. So there might be a couple of things I do here. So we can do divide by 5. Now, if you wanted to group this a little bit better, you could put parentheses around that part, but then you would have to put parentheses around the entire fraction 3 squared over 5. And we're going to multiply that by 4 divided by, and it's nice that Excel changes colors for you. It shows you where those parentheses are matching up, and we have 3 squared. And I did not add the closing parentheses, so it says, hey, I'm going to do that for you. And let me just expand that out so you can see how I entered that in. Given my decimal places 2 decimal places, I end up with 0.8. So I'm going to copy this over here and just turn that into a fraction. think we're good with 4/5, and we are indeed good with 4/5. So you just notice we have a little extra grouping to do here. I'm going to skip over number 2 and let's go to number 3. We have 6 times 3 divided by 6 to the second power. So if I copy that over, change that to a fraction, we know that's equal to 1/2. So we're good with that one. All right, I would like for you to compute number 4 and then compute number 5's, but let's put number 4's answer into the chat. So we're going to be looking at that. So write number 4 parenthesis, and then tell me what answer you got for number 4. And then when you get number 5, just mark number 5, label it number 5, and give me the answer for that one. So here the decimal and the fraction are the same. There might be a way for me to shortcut this. Since I have 3/2, 3/2, 3/2, and 3/2, 1, 2, 3, 4 times, that's the same thing as raising that to the whole power of 4. So let's see if we get the same answer here. So we had 7 divided by 3 to the 4th power. I'll just write the equation down below it. And since 3/2 is repeated 4 times through multiplication, I just raised that whole fraction to the power of 4. So we get 7/16, which is the same as 0.44. Any questions about that? Now, how do we do this by hand? So I'm going to switch back over to my iPad and just do a couple of these by hand. So mainly I want to focus on that second half, the ones where we have the squares and the fractions, because this is going to look more like the lessons that we're going to have over the next few days. So when I am simplifying the multiplication of fractions when exponents are involved, it's treated the same way we did multiplication of fractions before. We're looking to see what we have in common, and we're also looking to see what we multiply together. So here we have 3 squared times 4 over 5 times 3 squared. Since the 3 squared is available both numerator and denominator, that is going to give me the reduced fraction 4/5. Now, when we did that using using Excel, it did indeed give us the fraction 4/5, which is also equivalent to the decimal 0.80. All right, let's look at number 2 simplified by hand. We skipped over that one on Excel, but we can do this one by hand. Here we have 7 times 8 times 8 over 8 times 5 times 3. we see that we have one factor of 8 in both numerator and denominator, and there's left a 7 and an 8 factor in the numerator and a 5 and a 3 in the denominator. So that's going to give me 56 over 15. Now we can speed up the process of simplifying and multiplying these just by using the given problem. We see that we have 6 in the numerator, a 6 squared in the denominator over here. So we can go ahead and say, well, I'm going to take out one of these 6's because this is 6 times 6. So I get to remove one of those 6's. So I'm left with 3 in the numerator and 1 times 6 in the denominator. So this gives me 3/6, which is equal to 1/2 or 0.5. And that's exactly what we found when we did it in Excel. Now for problem number 4, we might have to know a little bit and be a little bit more familiar with what 2 squared is and what 3 squared is. So you might immediately say, well, 2 squared is 2 times 2, so that's 4. Well, that's the same number as this one over there, so that's going to cross reduce out. You also may say, well, 3 squared is 9, and that's the same number of the numerator here. So we're left with a 1 in the numerator, 1 in denominator, so that gives us a value of 1, which again is what you got when we did it in Excel. And for our last one, since we're multiplying all the way through, again, since I have base 3 here and I have these 3 bases here, we see these 3's that we see, there are 4 of them being multiplied. Well, that's equivalent to this one because 3 to the 4th is 3 times 3 times 3. So we have one of those is gone, 2 of those is gone, 3, and the 4th one's gone. So the only thing I have left here is now a 1. So I'm left with a 7 in the numerator and 2 times 2 times 2 times 2 in the denominator. 2 times 2 is 4. 4 times 4 is 16. So we're left with the fraction 7 over 16, which again is what we got in Excel. I think it's important for us to know how to do these by hand, as well how to input them into Excel. Now we're going to get into the content. These are all the prereq skills we need in order to be successful in our lesson coming up. And our lesson this week is dealing with units. So I'm going to switch back over here to my Excel sheet. And we're going to switch tabs to the tab that's labeled units. So what are units? Units are types of measures of different things. We have money units that are not listed here. We use units to specify length. The lengths can be in the US standard unit measure or in the metric standard unit. Oftentimes you'll see, oh, well, this is your height, for example, could be in feet and inches. Or if you are from another country and you use the metric standard, it might give your height in centimeters, depending on what the need is for that particular measure. We can also measure liquids, meaning the content or the amount of space that's taken up, very similar to like a volume, but we're looking at fluid ounces. So that is one way to measure a liquid, is a fluid ounce. Cups measure liquids. And also we know cups can also measure non-liquids as well, but in this context, cup is going to represent a liquid. A pint is a measure of a liquid, a quart, a gallon. And in the metric standard unit, we have liters, milliliters, and so forth. We can also use units to measure weight. The US standard units are like ounces, pounds, tons. The metric unit, you might see grams or kilograms or milligrams, micrograms. And then we also have units of time, like seconds and minutes and hours and days, week, months, and years. We have many, many more. Now, these three that you see here, all of these will give you a conversion chart. And if you have received your lab manual yet, or if you're online, you have access to your lab manual, um, there is going to be a page on the very last page of your lab manual, you will see a conversion chart. Now, if I switch over to this next tab, I do not have them on there yet, so hold on. Let me see where I have that. I do have a copy of that. Let me open it up for you. So this is what that looks like. The very last page of your lab manual. You'll see some conversion facts and formulas here. So these are the three sections I'm referring to. So these are the kind of things you do not have to have these memorized. In general, you will have access to these or it will be built into the problem. But you'll notice that what's not on here is time or money. So we're expecting you to know at least the currency of the US and how we track time. So please make sure that you are familiar with those. And we will go over a few of those in just a bit. So the first thing we're going to do, the whole goal of this unit is to do conversion of units. And to do that, we're going to use something called a unit cancellation table. This is a method I remember as a student learning in physics class at NC State a long time ago. And it changed my life as perspective to solving problems with units. Even setting up my math problems is something I use from that point forward. So it's a way to organize your information so that you're able to see how do these units impact one another? How do these fractions get multiplied one another? You'll notice that the way that these are set up is very similar to the way that we handled the fractions we were multiplying a few minutes ago. So a unit cancellation table is set up so all the units cancel except for the unit desired. To cancel a unit, the same unit must be in the numerator and denominator, just like those fractions. We can cancel out factors if they're the same on the numerator and denominator. When you multiply across the table, the top number will get divided by the bottom number, and the result will be your answer in that desired units, i.e., multiplying fractions. So here's an example. Suppose that, and we're leaving off all numbers just to start with. Let's just get familiar with how units behave. So suppose I'm going to take feet and I'm going to multiply it by the unit of inch divided by foot. I said feet, or I could say feet here, inch by feet, or foot times inch over foot. So we're going to handle that just like we would do a fraction, except that Excel can't do the calculations for us here. So what I did was I created like a little fraction here and just wrote feet divided by 1 times inches divided by feet. Now, if I handle these like fractions, what's going to happen to the foot? It's going to get divided out. So this unit is now gone, leaving me with inches in the numerator and it leaves me with 1 in the denominator. So the simplification or simplifying this foot times inch over foot simplifies to inch. Now the instructions here say simplify this and then classify the unit. Since I'm talking about inches, inches measures length. So I want us to become familiar with units and how they're used. So we're going to try a couple of these. You can either do this by hand or you can just type things on Excel. Totally up to you. There's no mathematical calculations here. It's just displaying. But I'm going to set this up and you should be able to type inside of your Excel as well if you would like. I'm going to type in, I have minute, I have weeks, I have days, I have hours, minutes, days, and hours. So if I multiply these three fractions together, I have minute over 1, and then I have all the other fractions. Multiplying straight across for my numerator, multiplying straight across for my denominator. But before I move forward, I want to see what things match up. Well, first of all, I see we have minute and minute. So both of those are going to get marked out. So if you want, I'm just going to gray mine out for that. So what I could do is just change my color. So they're gone. I also have days. They match up. So days are gone. I also have hours. They match up. So my hours are gone. So that is going to leave me with one unit, and that unit is called weeks. Now, weeks is a unit of time. So we're going to simplify these units by multiplying them together, reducing out the things that are going to cancel out, and then we're going to list what the name of that unit is and what it belongs to. So this first one is a unit of time. Let's try that again. For this one, we're taking pounds. So we're going to take pounds divided by 1. We're going to multiply it by milligrams over kilograms. And that's going to be multiplied by kilograms over pounds. And we're trying to figure out what that's equal to. Can anyone go ahead and tell me what unit this is of? All right, we can see that this is going to be milligrams, and that represents a unit of weight. All right, so we see that we have, and I'm going to show you some other formatting things in Excel. I'm going to copy this formatting I have up here. I'm going to highlight that cell, and I'm going to come up here to Format Painter, and I'm going to click on that, and I'm going to say I need pounds to go out. I also need kilograms to go out. So I'm just painting those cells, and that does indeed leave milligrams, which is a unit of weight. All right, let's look at number 3. Let's enter in these fractions here. We have a unit on top and bottom for all the fractions. So we have mile over hour. We have hour over minute. Have minute over second. And then we have kilometers over mile. All right. So we have mile is going to cancel out. We also have hours that are going to cancel out. We have minutes that are going to cancel out. And now we're left with kilometers over second. Or another way of saying this is kilometer per second. Now, because I have 2 unit measures here, It might not be so straightforward as to what this is measuring, but I bet some of you can tell me, what is this kilometer per second a unit of? It is indeed speed. All right, let's look at number 4. In number 4, we have feet squared, yards over feet, yards over feet. Now, if you would like, you could list feet twice. So we could do a feet here, feet here. That takes care of the feet squared. We have yards over feet and yards over feet. Totally up to you of how you want to list that out. That way you don't have to worry about putting the little caret symbol there. And when we do that, we're easy to see that we have the feet is going to disappear for 1, but we have another foot that gets to go away. So we're going to cancel out this next pair. And we see we're left with 1's in our denominator, but we have 2 yards left in our numerator. So this is going to be written as yard squared. And I have to put this little apostrophe in front, or otherwise the Excel thinks I'm trying to calculate something. So I'm just telling it to treat it like text. So we end up with y squared. Now, this y squared is a unit measure of what? Normally, yards represent length, but if we have length squared, that represents area. All right, this last one here. So we have inches, inches, inches. Since it's to the 3rd power, I have 3 of those. I have centimeters over inch, centimeters over inch, centimeters over inch. So what is this one going to be equal to? So we have inches gone. This inch pair is gone. We have this inch pair also gone. So I'm left with 3 of those centimeter units. So I have to have centimeters to the 3rd power. And when we have something raised to the 3rd power, what is this measuring? We said squared measures area. If we have an exponent to the 3rd, a unit to the 3rd power, and we're talking about length, that measures volume. All right, let's move on. If you just scroll over to the right, you're going to find 5 more examples. And in these examples, I've already done the solving for you, but you'll notice that there's something missing. So you have to figure out what's going in the missing blanks. So you've got to come up with what goes in these cells right here. So let's do the first one together. So for the first one, we have kilometers over meters, centimeters over millimeters, blank over centimeters, millimeter over blank. And we want the end result to be kilometers or kilometers, however you want to say it. Well, we know that this is one we need to stay, so we don't want that to get canceled out, but everything else needs to get canceled out. We need to cancel out the centimeters. We need to cancel out the millimeters. And we need to cancel out this meter. And that's what's missing up here. So we need to change that to a meter. Trying to find my colors here. So this is what's missing. And then what's going to go underneath millimeter? That's going to be a 1 because we don't want it to impact anything else. So now we have this also taken care of. So meters is gone. I guess I can go ahead and mark that there as well. So we've got this one gone, we have this one gone, we have that pair gone. So we have kilometers over 1. We're done. So that was our answer here. All right. Let me put a box around these that are missing. Makes it look weird though, doesn't it? All right, I think you've got the gist. For example number 7, tell me what units are missing. So we're going to fill in the rest of that fraction. So quarts needs to stay, so we want to leave that as it is. Let's leave that one alone because we want that to equal that. But we need liters to go away. And so we have liters goes here. It goes here. We need fluid ounces to go as well. But we notice that milliliters is left. So that means we're going to have a 1 in the denominator here. And the unit that is up here in the numerator in the missing place is milliliters. So now we can get rid of that. So now we have our quarts. All right, let's move down to number 8, finding the missing unit. So when you get the answers to number 8, write it in the chat, please. Type it in the chat. Yes, indeed. It is second. Very good. All right, let's look at number 9. And number 9, we have 4 blanks. I don't know if all of them are going to be used, but we need to end up with foot per minute. So we need this to stay. So that needs to stay. And we need this to stay. So we need inches and seconds to go away. So there's a couple ways I can write my answer here. I could put seconds here. I could put inches here, and there's nothing here, but just maybe 1 and 1, or we can just leave those blank. We don't even need them. So if I unhighlight those, we now have seconds is gone. Inches is gone. Leave me with feet over minute. Our last one here, we have a cubic inch times hour over minute times minute, and there's something missing, times something missing over inches, something missing over inches, times feet over something, and then we've got some empty cells here. So we have quite a few cells that we can use here. What do you think is missing? Tell me what is missing from the numerator. Type that in the chat. What units are missing from the numerator? Yep, there's 2 feet units that are missing. So let's go ahead and add those in. So that's going to take care of my feet cubed. So with that said, we need to get rid of this inches cubed somehow. So we know we have inches here. So what's missing is an inch here. So we need to take that out there. All right. Minutes is going to go away here. But we also have an hour that needs to go away. So let's talk about the denominator. What's missing in the denominator? So we have an hour that needs to go, and we need to introduce seconds somewhere. So what are we missing in our denominator? Again, I think this is going to be one of those where we don't need this, so there's your hint right there. I'll just go ahead and remove that. So what's missing here and here? So we need to introduce second. So I either need to put seconds over here or seconds over here. I'm going to put it over here. And again, it doesn't matter where we put them at this point. We'll get a little bit better at that later when we look at some actual conversions. So here now we see that our hours are going to cancel out, leaving us with 3 feet in the numerator. So that's going to be feet cubed and a second in our denominator. So all of this that we're doing on this tab here is very important, and it deals with the unit cancellation table. And this cancellation table is something we're going to need in order to do some unit conversion. So let's move on to our next tab. So in this tab of unit conversion, I have a couple things in here. One, what is unit conversion? Well, basically, we need a conversion factor. So a unit conversion is when we want to go from one unit to another. A conversion factor is going to be the number we use to get there. So a conversion factor is a number used to change one set of units to another, either by multiplying or dividing. Now we're going to use it using that cancellation table. So the conversion factors that we use are going to be expressed as fractions. So please make sure that you highlight that, because that's important, because the fractions are going to help us build our cancellation table. So for example, a conversion factor is what we're reading off of that lab manual. So for example, we might say, okay, maybe I'm doing a conversion from feet to inches. So a conversion factor would be 1 foot equals 12 inches. So we need to convert that conversion factor into a fraction. So either we would write 1 foot per 12 inches, or 12 inches per 1 foot. So your fraction can be written either way, reciprocals of one another. You have to choose the right one to put into your cancellation table in order for those units to cancel out. All right, so here's an example over here. So before we get to that conversion, that cancellation table, we're just going to practice writing our conversion factors. So for this first one, it says find the conversion factor for yards to feet and then express it as a fraction. So what I did in this example is I went down here and I was looking, I cut and pasted these from the lab manual, and I found that 1 yard is equal to 3 feet. So I wrote it in, 1 yard equals 3 feet. Now I express that conversion factor as a fraction. So I can either write it as 1 yard divided by 3 feet. And how I did that was I just underlined the numerator. Or I can write this as 3 feet divided by 1 yard. All right, let's practice this with example. You try number 1 and you try number 2. And then we're probably going to, we might have to move on because I want to get to some examples. So this first one here, let's do you try 1 and we'll do you try number 3, 1 and 3. So we want to convert from miles to kilometers. So we need to come over here to our table. And if we see kilometers, any kind of meter, we know we're dealing with the metric system. So we said miles to kilometers. We come over here and we find this measure here. It says we have 1 mile equals 1.6093 kilometers. So I'm just going to copy that and bring it up here for me to use. So 1 mile is equal to 1.6093 kilometers. All right, now how do I write this as a fraction? So I'm going to write it as 1 mile divided by 1.6093 kilometers. And if that's happening to you where it's chopping it off, that means I just need to expand. So you can take your cursor in between that column M and N and just drag it over. And I'm going to underline my numerator to make it look like a fraction. So this is one way I can write it. Or I can write it as 1.6093 kilometers over 1 mile. So this is how we will identify our conversion factor and then write it as a fraction. All right, I'm going to jump down to number 3 because in number 3, it says that sometimes more than one conversion factor is needed. So if we want to convert from ounces to tons, so we're going to come over here and we're going to just try to find the conversion factor. And if you find it, once you post it in the chat, what are the conversion factors I'm going to need? If I look in here, you probably are not going to find anything that directly relates on this sheet. Of course, it does exist, but just not on the sheet. Ounces to tons. So if I can't go directly from ounces to tons, what can be used in between? So maybe my ounces needs to be converted to something else, and then maybe that can be converted to tons. I see here that Stephen has posted, he said, well, we know that 16 ounces, so we have 1 pound is equivalent to 16 ounces. And we also know that 1 ton is equal to 2,000 pounds. So that means this first one could be written as 1 pound over 16 ounces. Or we may write this as 16 ounces over 1 pound. The second fraction could be 1 ton over 2,000 pounds. Or it might be 2,000 pounds over 1 ton. And again, this would be my fraction listed as it is here. Now, again, the reason why we're doing all of this is because we want to be able to convert from one measure to the next. So why don't we put this into practice? Let's hop over to the lengths conversion. And just a reminder, what do lengths units look like? They look like inches, feet, yards, miles, millimeters, centimeters, meters, kilometers. And I have an example here already worked out for you, just in case we didn't get through all of our examples, you have at least something to go off of and you can practice through. And you're more than welcome to follow up with me later and you can post questions in this chat. So here I have extracted out the tables that related to links. So we have the links over here, and then we also have some links over here dealing with the metric system. In my first example, it says convert 110 feet into yards. So if I'm going to convert feet into yards, I have to find its conversion factor. And that is 1 yard is equivalent to 3 feet. And I see it right here. So I just wrote it out. And then I expressed it as 2 different fractions. Now you notice that I've gone ahead and set up my cancellation table. I started with 110 feet and I put it over 1. And I need to figure out which fraction is going to make my feet units cancel out. Well, that has to be this fraction here. So I want to use the fraction 1 yard divided by 3 feet. When I do that, that's going to take care of the feet unit, and the feet unit is now gone, leave me with just yards. Now, because we're actually doing a conversion here, we have numbers attached. So we don't get to mark out the numbers per se, not unless they divide out. So we're left with 110 divided by 3 because 110 is left in the numerator, 3 is in the denominator. So I just divided that out and that gave me 36.67 if rounded to the hundredths place. So 110 feet is equivalent to 36.67 yards. All right, so it's your turn. Let's convert 5.6 kilometers into miles. And I want you to round to the hundredths place. So let's start with the given amount. So we have 5.6 kilometers. And let's find our conversion factors. So once you find your conversion factor, type that in the chat. So do we have a conversion factor that just converts strictly from kilometers to miles? I'm going to steal this little icon up here, rotate it around, because I see we have kilometers to miles right here. So let's use that. So we have 1 mile equals 1.6093 kilometers. Now we have to decide how to write the fraction. So are we going to put 1 mile in the numerator or 1 mile in the denominator? Well, we need to have the kilometers in the denominator so that unit will cancel out. So we need to put the 1.6093 kilometers in our denominator. Got some formatting issues here. There we go. That's going to leave me with 1 mile in the numerator. So now with that said, my kilometer units are going to cancel out. And that's going to leave me with 5.6 miles over 1.6093. And let me go ahead and just take out the miles for now. Just write this as a fraction. Let's go ahead and convert that. So that's going to be 5.6 divided by 1.6093. And that's going to give me this long decimal. So I'm going to take away some of those digits, round that to 2 decimal places. So my answer is 3.48 miles. All right, let's try one of these. I know we're only got 2 minutes left, but let's try one that is actually going to have more than one step in converting. So here we have 6,000 feet into kilometers. So we're going to start with 6,000 feet. And by the way, if we go over 4:30 and you have to drop off, please don't forget to complete the post survey before you leave. You can find the surveys on this first tab. This is the pre one that you should have filled out at the beginning. And this is also recording your attendance. And then this is the one you should be filling out at the end here. All right, so we have 6,000 feet. We want to convert this into kilometers. So that is our goal. Right, what conversion factors am I going to need? So question was, does it matter which conversion unit you use? Because I used the other one and got the same answer. That is correct. There will be multiple ways of getting the right answer. All right, so it looks like they've given us one unit measure. They're saying we have 1,000 meters is equal to 1 kilometer. So we do know that much. So I can go ahead and put that in there. So we have 1 km over 1,000 meters. So that's sort of a clue. So probably we're going to need some meters and feet here for my units to cross out. So what is my conversion factor that maps meters to feet? And if we go over here, we see it here. 1 meter is equal to 3.28 feet. 1 meter is equal to 3.28 feet. So we've got 1 over 3.28. So now we have our feet units cancel, our meters cancel, and we're left with kilometers here. So now we can do our calculation. In our numerator here, we have 6,000. turn off my formatting up here. In my denominator, I have 3.28 times 1,000. So now I'm going to have to calculate this. So this is going to be equal 6,000 divided by parentheses 3.28 times 1,000. We end up with 1.829. We're going to round that to 2 decimal places, and we get 1.83 kilometers. All right. Thank you for spending your afternoon with me. I hope that you found this module useful and something you can use in your upcoming classes this week to help you get prepared.